Okay, Precalc, we are starting a review on problem 6. The stuff before that was all about logs and exponentials, and that's the last cumulative test you guys just took. Some kids are taking today. So we're not going to talk about those right now, but I may circle back to those if you have questions about anything in 1 through 5. But on number 6, I hope you remember this will be one of the simplest ones we have. S equals theta r, and the only tricks are the arc length is S. If you're making a list for yourself of like stuff to study at the last minute, what I would do is put them at the bottom of the page. That way you can flip through your packet later and like go, oh yeah, that formula. I should memorize that formula. Where S is the arc, this is the radians. Don't forget it's in radians, as in the angle. But it can't be degrees. See, this says 20 degrees just to mess with your head. You can't put 20 in there. You got to change it to radians first. In case you forgot how to do that, it has to do with pi over 180 or 180 over pi. In this case, it's pi over 180 because the degrees can cancel that way. One on the top, one on the bottom, and then you reduce that. You put that in for your angle, and this is the radius. Terrible formula. Doesn't say A for arc. The radians aren't the R. The radians is theta, and the radius is another thing in there with radians. Hard to remember, but all you have to do then, once you know this formula, is stick your arc length in here if they give it to you, stick your angle in there if they give it to you, and stick the radius there if they give it to you. They'll give you 2 out of the 3 things you solve. Easy. Any questions on that? That's 6A, B, and C are all about that. You want me to actually finish it? Okay, I suppose I can. So you get that this 20 over 180 would reduce. Can you do that for me? Okay, so pi over 9. This is pi over 9. What is the arc length in this case? Doesn't say. So I'm going to say S equals. And, oh, right, 40. Okay. So then it must not tell me the other thing, which is the radius. Find the radius. Okay, I get it. Find the radius. All right, so R needs to be found. Come on, you can finish this. R is almost alone. What do? Divide by pi over 9, but you could clear the fractions deal. Remember that? Multiply by 9 to start with. That clears the fraction. And then if you want R alone, you're going to divide by pi. Radius is alone. 9 times 40 over pi. All right. If there's no calculators, which there is parts of the test, of course, where there's no calculators, if not all the tests. If they make it a no calculator test entirely, then all you have to do is write in something like this, and then simplify it as much as you can. Well, 9 times 40, you should be able to do that. 9 times 4 is 36, add a 0, 360 divided by pi. That'd be your answer on that one. Would you need to know what 3.14, 360 divided by 3.14? Come on. No, not realistic. Yes? There will be some multiple choice and some free response. All right, that's enough on that one. Let's move on to different kinds of problems. So much to cover, we can't afford to spend a ton of time on any one particular thing. All right, next thing is 7, 8, 9 in that zone. Okay, on number 7, it's a whole different kind than 8 and 9, so I'll show you this kind first. I know there's 2 spots where sign is positive. You got to remember that being positive or negative is a big thing in trig. This is positive 1/2. All students take calc, and sign is positive. That means it's got to be not here and not here. And therefore, it's going to have a triangle here and here. Are there 2 answers? Yes, there are. And now hopefully you just remember that sine of 30 degrees would give you 1/2. If you haven't memorized that by now, shame on you, you should have. But if you didn't, then you should at least have these guys memorized. 1, 2, square root of 3, and then you can go, oh yeah, the 30 is across from the 1, the 60 is across from the square root of 3, the 90 is across from the 2, and now I could say sine is opposite over hypotenuse, so from this angle's perspective, I would get the 1 over the 2, so it must be a 30. All right, so if this is 30, what's the other answer? It's a whole bunch of 30s. 5 30s to be exact. 5 times 3 is 150. So 30 and 150. But wait, it wants it in degrees and radians. So if I have 30 and 150, I got to change those both to radians. You can do that with that pi over 180 thing, okay? Or you can just have them memorized. I hope by now you've memorized 30 degrees. It's pi over 6. I know it's been a while. And how about 5 times that much? See, this is 5 times that much, so it'd be 5 times that much, which would be 5 over 6. Yes? No, it's a good question. You know what? It does not say here we should limit it to between 0 and 2 pi. I was assuming that, but now that I look at the directions, it does not say that. So since it doesn't say that you have to, like, limit yourself, technically there's an unlimited number of answers, because remember, sine goes like this, and it goes forever. So there's a zillion answers. So you make a good point. I didn't mention this in my other class, because usually we say something like find all the angles to, like, remind people. But I think you're right. Unless it tells me to stop, I'm supposed to find all the other ones too. So I should say plus 2 pi n plus 2 pi n. Thank you. That's a good point. All right. That's a topic. Now this one, root 3 over 3, a lot of people are tortured by that one because they're like, I don't have a triangle for that. Do you remember how to change this to something else? Something over something you do know? Well, you know it's got to have 1, 2 in the square root of 3 in it. Or it's got to be that other one, 1, 1 in the square root of 2. I've told you that the one that has the square root of 3 in it can be changed into a different fraction that also has a square root of 3 in it. And then logically, the square root of 3 can't be on the top. Otherwise, it would be the square root of 3 over 3 again. So if it has to have a square root of 3 in it, it's got to be a square root of 3 on the bottom. Then which ratio is the same as that? You can set it up like this. Root 3 over 3 equals I don't know what over 3. And you look at it and you go, well, what should it be? They cross multiply and be equal to each other. Square root of 9 and 3 times what? 1. That makes those equal to each other. So I just did all that work to figure out that that right there can really be 1 over the square root of 3. Now that I know that, I know I use this triangle. Now that I know that, I can set up my tangent. Where can I be? All students take calc. Tangent is positive, so it's got to be either here or here. And I draw my triangles. So many little things to know, but that's why we're reviewing it. And remember, most of you don't have your final for another week or so. Some of you, unfortunately, have it a couple days, but for you seniors. All right, moving on to, you have a question? It's wrong, or it's, okay, it actually can, but when they're all done, did they give the answer as an angle? Because remember, they already gave us the side lengths. They want an angle. That thing right there is an angle. What angle did they say? Okay, pi over 6 is the same as 30, so they're in the right triangle then. Okay. Okay, well, okay, so we have to finish this. Do you want me to finish this problem? I can finish this problem. Because the teacher that's doing that one is not referring people back to the original triangle. You can use those sides. It's just then you have to have memorized that this triangle is also the square root of 3 and double that, 2 square roots of 3, and square root of 3 times the square root of 3, which would be a 1 there. Those green ones that I gave you are another way to do the 30, 60, 90 triangle. I personally think it's better to figure out that this ratio is a triangle we already know, the red one, and then I can just not have to use all new numbers for it. So do you get that once I know it's this, then I know it's got to be that angle, which is, let me make sure here, which one would give us, tangent is 1 over root 3. It's that angle right there. It's got to be 30, also known as 30 or pi over 6. So it's right, it's pi over 6. Okay, but they use different sides on their triangle. All right, let's move on to the other ones, 8 and 9, where you actually draw pictures. Here's the two key words on these guys that everybody messes up: angle of elevation and angle of depression. Okay, the angle of elevation means you start with a horizontal line, and the angle of elevation goes up from there. Okay, so the angle of elevation here is 60. So if your triangle doesn't have that in it, you're doing something wrong. Then we do the other kind, which is down here. It talks about an angle of depression. So again, you would start with a straight line. This is the picture for this one down here. You start with a straight line and then say angle of depression is that angle. It's going down right there. A lot of kids will mess up and make their triangle this way, and that doesn't work because that's not an angle of depression right there. The red one is, the blue one's not. So I would use the red one as you're setting up that triangle for the lighthouse one. Okay, so this is the top of the lighthouse right here, where it shines the light out. Anyway, and then it goes down to a buoy down here. And then this is your angle of depression right here of 100, let's see. No, it doesn't say what it is. It says it's 120 feet this way, and it says that it's 10 this way. No, it's 10 degrees. My bad, I couldn't read that. This is 10 degrees right here. Once you have one side and one angle, you can find any of the other sides or any of the other angles using trig. So if they want to know how far is it, that's this distance right here. I'm going to move my 10 down a little bit here. I'm going to delete that. They want to know this distance right there. Then you use tangent of 10 is 120 over x. Okay, that's some trig. We have a lot more. I'm going to move down to 12. It's trig, but it's hard to tell how to get it set up. Do you get that if you have one side and one angle, from there it's got to be easy, otherwise you totally forgot your trig? Well, they told me one side of a triangle, but it's not the side of the whole triangle. It's that. They told me the altitude was 5. That's 5. Well, then they must have told me an angle. They did. By giving you an equilateral triangle, they've told you an angle. What angle is it? That's got to be 60. So then I can either figure out this distance here or this distance here. What they want is the length of a side. I would go with y, because if you find x, you're going to have to double it, because x only goes from here to here. Y is the length of a whole side. So I'd use that, and then I've got a side, and I've got an angle. And so I would go opposite hypotenuse. I do sine of 60 is opposite 5 over hypotenuse y. And then from there, you multiply both sides by y, and then divide both sides by sine of 60. You might be saying, how am I supposed to know what sine of 60 is without a calculator? Go off to your 30, 60, 90. 1, 2, square root of 3. And then sine is opposite over hypotenuse. From this angle's perspective, opposite hypotenuse. Root 3 over 2 is what sine of 60 is. And that's equal to 5 over y. And then I just have to multiply both sides by y, and then get the y alone by clearing the fraction, then dividing by root 3. Again, you got to be able to handle little algebra things like this at the end. Okay, this one, a lot of people have trouble with, hold on, this octagon question, because they get that you're supposed to do this, but then they're like, but there's no right angle in there. There's not. A lot of them can say that there's, okay, I know there's 360 degrees total, and so if I divide that by 8, I can tell how many degrees each piece is. 360 divided by 8 sides. Oh wait, is it 6 sides? It's an octagon, so it's 8 sides. Yeah, okay. So 360 divided by 49 divided by 8 would be 45. So if this is 45 degrees here, that's where they get stopped. Like, but I can't figure out the rest of it. It's because you haven't got a right triangle. So you split this in half, and then you will have a right triangle, and it'll be half of 45 right here. This angle won't be 45 anymore. Half of 45, 22.5, and this is now a right triangle. I'll take a little right angle right there, and I have a side because they told me the radius. The radius was 1 unit. That's 1. And now I have a side and an angle. I'll blow it up for you. This little picture right here. A little tiny triangle, side length 1, and this is 60. Now you can figure out any other side you want. I'd probably figure out that x side, and that'll be half of, because it's only right here, half of one of your sides. Didn't mean 60, and 22.5, thank you. Because I just figured that out right here. But that's 22.5. All right, that is a 22.5. Okay, so then once you have a side and you have an angle, you can do the rest in trig. All right, so, and then once you know how long a side is, the perimeter is easy. You just times it by 8, because there's 8 sides. Work through some more of your packet with you here. Solve for x in the given interval. And this one's particularly a pain because it's secant. Do you remember that the sister functions are sometimes easier to figure out? Like, you may not know secant, but do you know 1 over secant is 1 over 2? 1 over secant is also known as cosine. Now it's easier. You probably recognize it now. And they only want the answer between 0 and pi over 2, which means in my little picture, I only go between here and here. 0 to pi over 2. So I'm only supposed to go in that little quadrant. So when I make my triangle, there, once I've got this one triangle done, I'll be done. Because it limited me to only being between 0 and 90, or 0 and pi over 2. Okay. Again, I don't want to do all your problems. I just want to give you help on getting them started. Make sure you remember how to do these kinds. Okay, when they said sine is this, they're really saying positive. Sine is positive. Okay, that narrows it down. All students take calc. Sine's positive, it must be here or here. Can't be here, can't be there. Then, tangent is less than 0. That means tangent's negative. In which one of these is tangent negative? It can't be here. Tangent to be positive there. So if tangent's negative, it's got to be here. That's where my triangle goes. The sides are sines opposite of hypotenuse, 3, 5, and you can figure out that one by figuring out 5 squared and 3 squared and then doing something to them. You have to be able to find the third side of a right triangle. Certain things I have to be able to expect by now. Then, once you have that, you're supposed to be finding secant. Now, I could refer you to Cho Sha Kao. Do you remember that? Okay, but I have a feeling you're probably not going to remember that. So how about if you figure out secant's sister one and then flip it? What is secant's sister? Cosine. So we could find cosine and then make sure we flip our answer over because they're flipping sisters of each other. So if I find cosine in this, I go cosine's adjacent over hypotenuse, adjacent side, you have to figure out, over hypotenuse, and then you just have to flip it. So anytime you wanted, like, being asked to find one of those sister functions, that's, like, you don't have memorized, because you didn't memorize Cho Sha Kao. Sha, I mean hypotenuse over adjacent. It'd be a lot faster. Here's hypotenuse, here's adjacent. So it'd be 5 over the unknown square root. Okay. I don't have much time left, so I'm going to stop there for today. That should get you through number 16. And I will resume more questions on the packet tomorrow. We'll do a good, thorough day of review of your packet tomorrow. Then seniors, you'll be starting your test on Friday. Everybody else, we have Friday and Monday to review still. And that's all I have for you for today.